Everyone, I'm Jianyu.
I'm Ying.
Here is our final data mining project. We are going to discover the knowledge behind the Citybike data. So Citybike is the largest bike sharing program in the United States. This program can reduce traffic load and air pollution to a certain extent. From our point of view, it's reasonable to follow the CRISP-DM process, which is learned in the class, to analyze the data. The first step is the business understanding. Citybike needs to allocate a large amount of bike every day. Thus, it's definitely helpful if they can know overall bike demands in advance, which means we have to predict the overall bike demands. And moreover, user analysis is also important because as the company, the primary goal for it is to make money. If we can figure out the insight that which kind of people prefer to use bike at which time, it is absolutely useful for Citybike to design proper plans to encourage people to use its service. So in the end, our project aims at providing New York City Bike Company better marketing campaign and operation planning. The next step is the data understanding. Data understanding has three steps. The first step is the data collection, and one of our dataset source is from the New York City Bike official website, which includes the City Bike trip historic data. And we also have every 5 minutes real-time data retrieved by our Gyro program, and the file is the JSON-based. And we also combine the weather data from the Weather Ground website. The next step of the data understanding is to assess data quality. And as we can see that Citybike trip data and real-time data is not complete. The completeness of this data distributed by the months. For example, the December has the highest completeness, which is the 94.45, and April has the lowest completeness, which is the 26.82. And for the weather data and bike demand data, they are all completed. And the last step of data understanding is exploratory data analysis. In order to summarize the main characteristics of this data, it's quite useful to use visual methods to analyze them. Bike demands here can be calculated as the number of records because one trip duration is made by one bike. From the line chart above, it's easy to see that bike demands number of records are really high from August to October. However, when it turns to valid records among these 3 months, October is more reasonable to use, for it has the most valid bike demands. Moreover, the weather data and bike demand in October will be explored as well. And the next step is the data preparation. At first, we have to cleanse, prepare, and transform data set for Citybike trip data. Because there are many missing data in the Citybike trip data set, we have to do some preparation before using them to create modes. Our goal is to figure out customer habits when borrowing bikes. So if there is any missing attributes of this person is missing, such as user type and the year of birth in this case, the value of this group of data will be declined significantly. So our method is to delete all the missing ones, and we assume this is a realizable method to prepare data. For the weather data, in order to reduce variables, we will ignore those highest and lowest a number of characterized, such as humidity and the temperature, and so on. The next step is to prepare for modeling in subsequent phases. Since our goal is to see the bike demand schedule over different kinds of person, it's necessary to convert year of birth to age directly. As the table above, the max number of age is 132, which is obviously abnormal. Thus, those outliers should be dropped, and here is the age greater than 90. After adjusted data, the following table is more reasonable. And the last step is to select case and variables appropriate for analyze. And as our goal is to see the bike demands schedule of different kind of people. Age and start time are variables will be used in our analysis. So in order to make our project more useful, we will not include all 24 hours data. Based on the plot above, we can see that 8 to 9 a.m. and 5 to 7 p.m. are most valuable time. Moreover, instead of investigating the relationship between weather condition and each station, we choose to combine real-time bike demands of each station to get an aggregate demand of the whole New York City. The reason to do it is that the population change of each station might be large to a certain extent, but the overall residence in New York City is stable.
Now, let's go to the modeling phase. First, we propose several hypotheses. Then, we use models to verify them if everything goes well, of course. However, if the result of model cannot support our hypothesis, unfortunately, we have to reject our hypothesis. After all, we have to respect the fact based on the model. The algorithms we use are association rules and regression model. We assume that residents in New York City who are in the middle age are more likely to use city bike service. There are several reasons. People in middle age need to go to work in the morning and back home in the afternoon. This is almost a daily routine for them. Actually, people in middle age cares more about their healthy problem. They are more likely to choose bike to commute. It's a common sense that the weather condition will change your mind. I mean, whether or not you will choose bike to go outside. After all, no one wants to ride a bike in a cold, raining day. That's why we think it is possible to predict next certain hours bike demands based on historical data combined with weather information. Here is the first 5 rules we found after running VECA based on association rules. We can conclude that people are more likely to use bikes in the time interval between 8 to 9, 17 to 18, and 18 to 19. Also, people who are in which is really consistent with our common sense because these are traffic congestion hour and people need to go to work and back to home at that time interval. Moreover, people who are in 30s and 40s are main force who'd like to borrow bikes, and most of them are subscribers, in other words, annual members. Time series models captures elements of certain stations such as 17 station number 72 very well, and the prediction results are good to a certain extent, but results of other stations are quite bad, such as station 128, whose significance is 0. The reason may be that the bike demand at each station can vary with a variety of factors. It can extremely dynamic if sudden social events or traffic accidents happen, which can create uncaptured outliers. That's why we assume aggregating hourly data into daily data is a good choice. Actually, regression model is a good choice for determining correlation between continuous targets and their predictors. By auto modeling function provided by SPSS modeler, regression model is a good choice. It seems that mean visibility and humidity, sea level, pressure, and cloud cover are the most important factors to affect the amount of bike in New York City. The R-square of our model is 0.77, which is not as good as we expected, but it's still quite good. On the evaluation phase, we use random trees, decision trees neural network KNN algorithm to do the comparison. It turns out CNR decision trees is the most effective one. The correlation of it is 1 and the relative error is 1.008. But it might have overfitting problem. You can see the regression model we use is the number 3 is listed as number 3, still quite good among those models. Well, let's go to the suggestion part. City Bike Company can promote advertising campaigns focused on people who are between 30 years and 50 years old. They use bikes a lot. Moreover, it is also a good idea to design decent discounts for members, like reducing annual fees if people use bikes exceeding certain times. As to the prediction area, our predicted demand for next 3 hours is not as good as we thought. But it's still an overall guideline for City Bike Company to allocate its bike resource. Hopefully, our findings is useful for City Bike to attract more new customers and make more profit. Thanks for your time to view our presentation. That's all.